Welcome once again. This is another exciting session of mathematics where maths has been made very easy. Today I want us to discuss trigonometry. I'm here to take you through this session where we'll just look at the first part of trigonometry, and my name is Peter Skasula. In the introduction, trigonometry deals with the relationship that exists between the sides and the angles. The sides and the angles. Now, these sides and the angles, we're talking about the sides and the angles in a triangle. Basically, there are a lot of types of triangles, but our interest in this session is just on a right angled triangle. Then these other triangles, we just name them as other triangles. I'm not going to go into details classifying the triangles. No, what we should just know is there is a right angle triangle, and if it is not a right angle triangle, then it is any other triangle. Okay, so under this session we can discuss the three trigonometric ratios, or which we can write in a short way as the three trig ratios. So the three trig ratios. Now, which ones are these three trig ratios? The three trig ratios, they are all about a right angle triangle, and in a right angle triangle, these are the concepts or the terms that you are going to meet. One, we have the hypotenuse. This is the hypotenuse here. The hypotenuse. Now, what is so special about this hypotenuse? It is one opposite to the 90 degrees angle. This angle here is 90 degrees. Okay, when you come across this one, or you see this, then we are saying it's 90 degrees. So the hypotenuse, it's opposite to the 90 degrees angle. The other thing about the hypotenuse is it is the longest side. So longest side, this is the longest side in a right angled triangle. Then, depending on the angle that you are talking about, if we consider theta here, its opposite will be this side here. Okay, the side AC, from A to C will be the opposite. Then the other one below here, AB, is the adjacent. So these two sides, the opposite and the adjacent, they change depending on the angle that we are considering. If we are to change theta, we'll bring it here. If we bring theta here, you see that its opposite will become this one, and the adjacent will be that one. So these, they are not fixed, but they can change. But for the hypotenuse, it doesn't change. In a right angle triangle, we call it a right angle triangle because of the 90 degrees angle. When you find the 90 degrees angle, then it is a right angled triangle. So if you find this one, as I explained earlier on, then we call it a right angled triangle. Okay, now since we said there is a relationship between the sides and the angles, you see that the hypotenuse is the longest side, and since it is the longest side, you can also make mention of the fact that in a right angle triangle, the largest angle is the 90 degrees angle. The right angle itself, it is the largest angle. These other two, they will share the 90 degrees that will remain, because in any triangle, the sum is 180 degrees. Okay, now how do we find the sides and the angles of a triangle? Okay, we can use the three trigonometric ratios or the three trig ratios, and these ratios are the sine, the cosine, and the tangent ratio. So the tangent ratio, the cosine ratio, and the sine ratio. Now these, they have been given in terms of the sides. So the sine ratio is given in terms of the opposite over the hypotenuse. So the opposite of the angle in question over the hypotenuse. The hypotenuse, we have said, the longest side. And in the short form, we can write to say sine is equal to O coming from the opposite and H coming from the hypotenuse. Okay, then equally for the sine, we are saying it's given in terms of the adjacent over the hypotenuse. So in short form, we are saying cos is equal to adjacent A coming from the adjacent, H from the hypotenuse. For the tangent, we are saying it's also opposite over the adjacent, and in short form we say tan is equal to opposite over adjacent. Okay, from there, for the sake of easy memorization or remembering, we are saying if we get S from sine, S, then S is in terms of the opposite over the hypotenuse. Then from cosine, we're just getting C, and cosine is in terms of the adjacent over the hypotenuse. Then on the tangent ratio, you're just getting T, and it is in terms of the opposite over the adjacent. So for you to easily remember these three trig ratios, we are saying for the sine, it's just so this word so. Then for cosine, it's this part here, ka. Then for the tan, it's toa. So someone said for me to remember easily, I'll use the word sokatoa. Okay, that's where the word sokatoa comes from. So this is the word here, sokatoa. Alright, we can quickly go to example 1. Okay, it's saying the diagram below shows triangle PQR in which PR is equal to 9 centimeters. So this is PR here. The angle PRQ is equal to 50 degrees, this angle here. And the angle PQR is a right angle. So PQR, this angle here, is a right angle. And when we say right angle, we are just saying it's 90 degrees. So we are not going to tell you to say it's 90 degrees there, but you should know when you come across the word right angle, it means 90 degrees. Find the length PQ. So we want to find the length PQ. This is the length here, from here to there. Okay, this is the length that we are looking for. Okay, you can apply SOHCAHTOA there. So for the solution, we are saying, first of all, you can write SOHCAHTOA. 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 So you need to look at what is given, what is available. Here we are given the line PQ. For your own information, the line PQ, since it is the opposite to the 90 degrees angle, this one here, this one means it's the hypotenuse. We are given the hypotenuse there. The hypotenuse is given. This one is H, and it doesn't change, it's just the same. So we'll look at the trig ratios that have got h. Here we can see that there is h and there is h. So possibly we can use the cosine or the sine. Now let's go further by looking at what also is given. We are also given the angle 50 degrees. Okay, angle 50 degrees here. We are given angle 50 degrees. So we are looking at anything that will give us over the hypotenuse. So if we say this angle has got the opposite is PQ. Okay, PQ is the opposite. Then the opposite, you can say opposite over the hypotenuse. That one will give us a sine. So we are saying sine is opposite over the hypotenuse. So the suitable trig ratio to use here is sine. So we'll say sine. Okay, sine the angle, sine theta is equal to the opposite over the hypotenuse. Okay, the opposite over the hypotenuse. We can proceed. We are saying it's sine 50, the angle is 50, we are given 50 degrees, is equal to the opposite in this case is PQ, because that's the opposite of angle 50. The hypotenuse is 9. From there we know that sine 50 is over 1. We can cross multiply, and if we cross multiply, we're going to find that 1 multiplies PQ. So we are going to say 1 times PQ will give us PQ is equal to 9 times sine 50. We write 9 times sine 50. You can proceed by saying PQ. When you do the calculations on the calculator, you can just punch 9 multiplied by sine 50. It is going to give us 6.8943999881. We can maybe just round off to 2 decimal places because that's exam standard. So we are going to have 6.89, and these are centimeters because we are finding the length PQ. So the length PQ will just give us 6.89 centimeters. Alright, we can proceed and go to question B. Example 2. Example 2 is saying the diagram below shows the right angled triangle. Okay, so this is our triangle here, and we are saying find the value of cos theta, then sin theta. So we'll go direct into the solutions. In the triangle, of course, we have seen that we are given 12 meters. We are also given 5 meters here. We are given the angle theta, and we are also given the 90 degrees angle here, and this length here is the longest length, and that's the hypotenuse. So we are asked to find cos theta. How do we find cos theta? We write SOHCAHTOA. So for the solution, first of all, we are saying SOHCAHTOA. Now this one is not part of the solution, it's just here to help us identify which trig ratio we are using, which one is suitable. So in the first place, for us to find cos, it's adjacent over the hypotenuse. Now in this case, for the hypotenuse we don't know it. How do we find the hypotenuse? The hypotenuse can be found by using Pythagoras theorem. Pythagoras theorem states that if you have a squared plus b squared will give you c squared. Now in this case, the way the letters are arranged, you see that a, its opposite is that one. So we'll say in this case we are going to use the letter a for the hypotenuse, so a squared, because this is the small letter a, the opposite to angle a squared is equal to this 5 meters here, its opposite is angle c, so this one will be small letter c. B, angle b, its opposite is that one, so small letter b, so we'll say c squared plus b squared. All right, for us to find a squared, we'll say, we proceed, a squared is equal to c squared, we have said it's 5 squared, plus b squared is 12, so we are replacing, say 12 squared. We're going to have a squared is equal to 5 squared, just simply means 5 times 5, so here we can write to say 5 times 5 plus 12 squared simply means 12 times 12. Okay, from there we can proceed. We can have a squared is equal to 25. 5 times 5 is 25 plus 144. 12 squared is 144. Then we can continue. We can have a squared is equal to 25 plus 144 is 169. Then we take the square roots. Okay, now someone would ask to say, why is it that here we are not having positive or negative? It's because we are dealing with the length, so the length should not have a negative. The distance is not negative, the distance is always positive, so a is equal to the square root of 169 is just 13, so we are saying the hypotenuse therefore is 13 meters. From there now we can now find the value of cos theta. Cos theta, we are saying it's opposite over hypotenuse, so we can say a cos theta will give us opposite over hypotenuse, and we are saying the opposite of the cosine, the angle cos, the theta, the angle theta I mean. Okay, angle theta is here, so its opposite is just the length in front of it, so this length here, so we are saying 12. Oh, the cosine we are saying it's the adjacent over the hypotenuse. Okay, so the adjacent over the hypotenuse, here we are saying adjacent over the hypotenuse, so we are saying not this one. The adjacent in this case will just be the length below here, the length below, which is this length here, which is a 5 meters over the hypotenuse we found 13. So here we are not saying the opposite, it's the adjacent. Okay, so it's adjacent over hypotenuse, the adjacent over hypotenuse, so it will just be a 5 over the hypotenuse we had found 13, and this is our cos theta. Then for b we are saying sine theta. Okay, sine is the one that is opposite over hypotenuse. Okay, so the opposite, we go back to the diagram. The opposite of this angle is just the length in front of the angle, and we are saying it should be 12. So we have found 12, the hypotenuse is 13, and this will be the answer. Okay, thank you very much.